Hello everyone. Today we're going to be finding volume by cross sections. So the very first thing is to read through and find the region that we need to be focused on in the XY plane. So as I'm reading through here, it says the base of a solid is the region enclosed by the x-axis, the y-axis, and the graph of y equals 1 minus sine of x. So we're going to attempt to graph that region, and it is good to be able to graph these by hand, even though for the most part you'll have a calculator to be doing the integral at the end. It's still a time saver if you know how to graph it by hand. So we have the x-axis on here and the y-axis, and then the graph of 1 minus sine of x. Well, if you remember back, sine of x looks like this. So with the negative in front, the minus sine of x part, that's going to reflect it over the x-axis like that. And then the plus 1 is going to shift that up 1. So I'm going to get rid of those two curves. And the 1 minus sine of x curve looks like this. And then it keeps going. We're not going to need all of that, but that's what it looks like. So the region that's enclosed by the x-axis, the y-axis, and the curve ends up being that kind of triangular shape. It's not exactly a triangle because it's curvy on one edge, but that's the base of our solid. So now we're going to show the cross sections, which they said run perpendicular to the x-axis. So as soon as I read that, I always draw just a little cross section, run like this. It'll work. There we go. Perpendicular to the x-axis. So that's that little segment right there. But the whole entire cross section, they said, is an equilateral triangle whose side lies in the XY plane. So that line I just drew is just one side of the equilateral triangle. So the rest of the triangle is basically coming up and out of the picture. And there would be an infinite amount of those equilateral triangles. So maybe just to make it a little bigger, I'll just draw only that triangle. And think of it in 3D as coming up and out of the picture. What you need to do to find volume by cross-section is to be integrating the area of the cross section. So really the only tricky part is to figure out the expression for the area of your cross section, which for this is an equilateral triangle. Well, there is a formula for equilateral triangles, and you might have seen this in other classes like geometry, but an equilateral triangle, the best equation to use for its area instead of 1/2 base times height is side squared rad 3 over 4. That's a formula that comes about because of the equilateral triangle having 60-degree angles, and when you draw the height, you end up with a 30, 60, 90 triangle, and you end up getting this formula for the area every time. So I would suggest using this formula for the area, and the only part of it that's a variable is the s, and the s is the side of the equilateral triangle. Well, this first side that I drew ran from the curve down to the x-axis right there. So the length of that side would be when you subtract the curve minus the x-axis, or think back to when you did areas, which would have been a little earlier in this particular chapter, which would be, they would have explained it as doing top minus bottom. So the length of that side, top minus bottom, is the curve, which was 1 minus the sine of x, minus the bottom, which is the x-axis, which means that's just minus 0. So this right here is s. So I just made a little more room, and now I'm going to write into my integral the area of the cross section, which would be the s squared. So that would be 1 minus sine of x minus 0, which I don't really have to write, squared, rad 3 all over 4 dx. And then the last thing I need to do is find the lower limit and the upper limit for x, because everything is in terms of x. So this would be the leftmost x, and the upper number is going to be the rightmost x of the yellow shading. Well, the x on the left is 0. So we just have to figure out what this x right here is. And the sine, though 1 minus sine of x curve is going to touch the x-axis at pi over 2. Now, if you didn't know that, you could just set 1 minus sine of x equal to 0. And you could solve. So that would end up being 1 equals the sine of x. So you're saying, where does the sine of x equal 1? And on the unit circle, you would know that that's straight up at pi over 2, because sine is the y coordinate. So that's going to make me, I'll just make a little room here. So that's going to make the upper limit pi over 2 and the lower limit 0. So it's from 0 to pi over 2. So this is our integral right here. Some problems or some tests that would be without a calculator would just let you stop right here and circle this as your answer for the volume. But otherwise, I would just pull out your calculator and do the integral on the calculator to get your final answer. So I just punched this into my calculator and I get approximately 0.6617 for the final answer. Now, there are some really frequent cross sections that they use, and it's helpful to know their areas. So let's just go over the most common ones. So here are some of the most frequent cross sections. What you want to do for every single one, though, is draw in that little line segment that runs perpendicular to the x-axis, because that's what the problem said. That little line segment is going to represent something important in each one of these cross sections. So in number 1, it says the cross section is a square with the base in the xy plane. So that little line segment is going to be the base of the square. Every part that says blank in the xy plane, that is what that line segment is going to represent. So I just underlined those. So the underlined equals the line segment that you drew perpendicular to the x-axis. And the length of that line segment, remember, we just said it's the simple top minus bottom. So the length of that line segment was 1 minus the sine of x minus 0, because it was just top minus bottom. Now we don't have to keep writing the minus 0 portion. But so for number 1, where it says that it's a square with the base in the xy plane, well, then that just means the square is coming up in a 3D fashion, up and out of the picture. And the area of a square is side times side, because it's just like base times height, but everything is the same length. So the area of the square, which you'd put next to the integral, is just going to be side squared. And the length of the side is the length of that little line segment. So it's just going to be 1 minus the sine of x minus 0, I'm going to leave off, squared, dx. And I'm not going to try to squeeze in the limits, but it's from 0 to pi over 2 each time. Then let's see if we can erase the square I just drew. Okay, now number 2, it's a square with the diagonal in the xy plane. So that little line segment is now the diagonal of a square. So that means that it's gonna look kind of like this. I'm not really that great of an artist, but there we go. So you have to picture that's a square, and it's the diagonal that's running in the xy plane. Now, there's a handy little formula for the area of a square if you know it's diagonal. You can just say that area is 1/2 times the diagonal squared. And all of these area formulas come straight from geometry, so I'm not going to go back and prove how they work, but that would work for the area of a square. So it would be the integral of 1/2 times the length of the diagonal, which is still that line segment, so it's still 1 minus the sine of x minus 0, and then that would be squared. All right, now if we move on to the next one, try to get rid of this last one. Just leave those other dots in there. Now it's going to be a circle with a diameter in the xy plane. So that line segment is the diameter of a circle. So imagine you have the circle like that coming up and out of the picture. So I'll just write in here that that line is the diameter. Well, you know the area of a circle, it's pi r squared. So if the diameter is, I'll write it over here, if the diameter is 1 minus the sine of x, then the radius would just be divided by 2. So then the area of that circle, we'll stick it next to the integral, and the area would be pi times the radius, 1 minus the sine of x over 2 squared dx. All right, and then the final cross section, let's just erase this stuff. And we'll put that line back in. So the final cross section says that it's isosceles right triangles with the base and the xy plane. Okay, that's going to look like this. So it's the base of the triangle. So here we come up and out, and then connect it back down. There we go. And this will be our right angle. So now this right here is the base of the isosceles triangle. This one, I think it'll be helpful to draw the triangle outside of the picture. So here's what we have, the 90, and then here's the base when you're looking straight at it. So that's, again, that line segment, which we've already been saying is a length of 1 minus the sine of x. Well, here's the thing. They said it's an isosceles triangle. So that means the base and the height are equal. So the height is also going to be 1 minus the sine of x. And we know the area of a triangle, just the basic area, is 1/2 base times height. So it's pretty straightforward. Now the area of all of those triangles, we'll have that in the integral, and it'll be 1/2 times the base, which is 1 minus sine of x, times the height, which is also 1 minus sine of x dx. And from 0 to pi over 2, that would have been those same two numbers on all of the integrals that I just wrote in numbers 1 through 4. And yes, you could write 1 minus sine of x squared if you want to write it in a little bit more shortened version, like that. And I started dropping the minus 0. So it really was 1 minus the sine of x minus 0, because it was top minus bottom for every single problem, but there's no reason to keep writing minus 0. And those are the most common cross sections that you will have in your homework problems. So hopefully that will help. And then if there's any other cross sections that they throw at you, hopefully the idea behind this will help you to figure out what their areas and the length of their sides and things will be. That's it.